Before being able to mint, we have to deploy our scripts. Remember that we use our collateral validator and minting policy as reference scripts, so we have to deploy them before using them. For that, we use this deploy both scripts in one transaction off-chain function. We do a few checks to make sure that we have the values that we need in the current state. And here starts the fun part. We have to get the final minting policy. Why? Because if we go to the minting policy on-chain code and we go to the top, we see that we have to parameterize the minting policy with the oracles validator, the collaterals validator, and the collateral min percent. We will go over how they interact with the transactions in the minting video. But for now, we know that we have to provide this value. So if we go to the very bottom, we see that we have the policy code lucid that takes the policy lucid function that is right here. As you can see, we built the mint params value with the three parameters we passed to these functions: the oracle validator hash, the collateral validator hash, and the min percent. These three values. So these three values are the ones that we have to provide to get our final minting policy. If we go back to the deploy script React component, we apply those parameters with the get final minting policy function. If we go inside, we see that the first thing we do is to create the token name. This token name USDP has to be the same that the one we hard-coded in the minting policy and collateral validators. We see about that in the next video, but we have to use this USDP and use this from text function to take this UTF-8 text and convert it to hex. Once we have the token name, we have to get the oracle validator hash. We do that by just using this validator to script hash and applying it to the oracle script. We have the oracle script because we are deploying the scripts after deploying the oracle. So as soon as we deploy the oracle, we save this oracle script in the front-end's global state, and that's where it comes from. Then the collateral validator hash, we use the same, but in this case, the collateral script is hard-coded because it doesn't have any parameters. If we go to the collateral and we go to the top, we see that, or right here, we see that we have the collateral datum, then the collateral redeemer, but no parameters. So this collateral will be the same no matter if we change the minting policy or the oracle. Let's go back to the deploy scripts. So now that we have the two validator hashes, we do a console log for good measure, create the parameters. As we saw in the minting policy, it took the validator hash of the oracle, the validator hash of the collateral, and the minimum percent. So we create this type based on that structure and use the apply params to script function to apply to the code we got when saving our minting policy code and to the collateral validator hash we generated. And this min percent, we get it from the UI. The user chooses in the UI which minimum percentage of collateral has to be logged to be able to mint. Once we applied the script to all those parameters, we get the final stablecoin policy from which we can apply this minting policy to ID function to get the policy ID. And once we have the policy ID and the token name, we can create the asset class of the stablecoin by joining them together. And that's it. Now we got everything we need. We update the state. This is just updating the state, creating a potential state update in the case that the transaction succeeds. And we return this potential state update that contains the policy ID in hex, the token name, and the asset class, etc., etc. Now that we got all these values, let's go back to the previous function. And we check that we actually could generate the minting policy and create the transaction. The only thing the transaction needs to do is to deploy the scripts. It has to attach the script to a UTXO. So we do the same time twice, but for different scripts. We pay to an address with data. In the diagrams, I use the always false validator. But in our case, we're going to use our own address to get the scripts and keep control of them because this is just testing. We provide an inline datum of void because we don't really care, and the script reference that contains the collateral script. As value, we provide nothing, and then when we balance the transaction, it will provide the amount of ADA needed to generate the UTXO. We do the same, but in this case for the minting policy script, and balance the transaction, sign and submit. And that's it. After running this function, we have our collateral and our final minting policy on chain to be used.